Imagine our planet where the conditions we are used to have completely disappeared. As a result of the destruction of the ozone layer, the world has turned into a continuous icy desert, where all life is constantly destroyed by unrestrained solar radiation. This picture may seem like a description from a feature film. However, these are the consequences that await our planet if a powerful gamma burst occurs somewhere near us. The damage from this will be comparable to the explosion of several million atomic bombs in the atmosphere. Every day, at least one gamma ray burst is recorded in different parts of the universe, and the most powerful of them was noticed relatively recently, on January 14th, 2019, using the Magic Telescope on the island of Palma. The observation was initiated by gamma ray satellites. After 57 seconds, the Magic Telescope began to register in gamma rays with an energy of up to 1 trillion electron volts, which, for comparison, exceeded the same indicator of visible light by billions of times. The event was named GRB 190114C and was the strongest signal ever recorded in the history of observations. Such a high power undoubtedly pointed to the detection of the most high energy photons ever detected. When the gamma ray bursts were recorded, the source GRB 190114C was located at a distance of more than 4 billion light years from Earth. This meant that the path of its light to us took about a third of the age of the universe. In order to understand the nature of this phenomenon, the Hubble telescope was involved, with the help of which it was possible to determine that the explosion occurred in a very dense environment, that is, right in the center of a bright galaxy. Its source was most likely a collapsing star. The material was moving towards us at a speed that reached 99% of the speed of light. Despite the global nature of such phenomena, such gamma ray bursts can be called extremely rare. As a rule, their sources are located billions of light years away from our Earth, and only a few such examples can be found in each galaxy. It is believed that all the bursts recorded so far have occurred outside our galaxy. After all, one such outbreak can lead to serious consequences for all living species in the galaxy. And the reason for such destructive power is that in a few seconds, a gamma ray burst releases as much energy in a few seconds as our sun would release in 10 billion years of continuous shining. The GRB 190114C, discovered in 2019, can undoubtedly be called the most powerful gamma ray burst in history. However, we have already observed a similar phenomenon before. The first such outburst was accidentally recorded on July 2nd, 1967, using the US military Vela satellites. Soon after, the same satellites detected 15 more unexplained gamma ray bursts. As new mysterious flares were observed and studied, hundreds of models were proposed to explain their origin. And between 1973 and 2001, more than 5,300 scientific papers were published on gamma ray bursts. Over time, the nature of this phenomenon became clearer, only through further the study of supernovae. Researchers were able to finally link the origin of such flares to the deaths of supermassive stars in distant galaxies. Today there are many assumptions about what can cause such a powerful emission, and the leading concept is the theory that gamma ray bursts occur when the merger of two neutron stars. Another possible theory is a scenario in which a gamma ray burst results from the formation of a black hole. In this case, a powerful stream of charged particles bursts from the vicinity of the black hole in different directions, interacting with magnetic fields and cosmic radiation to produce gamma rays. This flux is so powerful that our satellites are able to record similar events that occurred at a distance of more than 10 billion light years. However, even though such outbursts are being recorded more frequently today, the process of studying them is far from over, and they still remain one of the biggest mysteries in astrophysics. We know very well that we are close to such an event. The likelihood of the rapid extinction of our species would be far from 100%. The fact is that the lethal outcome depends on the location relative to the gamma rays, and the location of an object in the danger zone is called getting into the cone. In a galaxy as large as ours, gamma ray bursts occur about 2 or 3 times a century, and in our immediate vicinity, once every 100 million years. The need to get into the cone further reduces the risk of our civilization being destroyed by a gamma ray burst. This figure increases by measuring the period of occurrence of outbreaks that are deadly for the Earth, up to 500 million years. However, it is believed that such outbreaks have already had an impact on our planet in the past. For example, in 2012, a team of researchers from Japan discovered that perennial Japanese cedars contain unusually high levels of the radioactive isotope carbon-14. At the same time, high levels of beryllium-10 were found in the Antarctic ice, indicating that several centuries ago, a powerful energy flow was affecting our planet from space. Following this, scientists determined that a strong energy release could have reached the Earth at the end of the 8th century. And even though the radiation was quite strong, people in the Middle Ages could hardly notice it, if the gamma ray burst really happened at that distance. Our atmosphere most likely absorbed the radiation wave that reached it, leaving a trail of isotopes that were eventually preserved in cedars and glaciers. Theoretically, it was the gamma burst that could have triggered the second largest, the Ordovician-Silurian extinction, the second largest in the history of the Earth. As a result, about 60% of living species disappeared on the planet. Previously, such a powerful event could have gone unnoticed, but today, scientists can detect and identify a gamma ray burst within 1 minute. This became possible thanks to the SWIFT satellite, launched in 2004, the Fermi Space Gamma Ray Telescope, and the Italian Agile Orbiting Observatory. In theory, gamma ray bursts can play an important role in the process of studying the distant reaches of the universe. We can see them from vast distances, thus gaining information about the structure and evolution of the early cosmos. Each gamma ray burst is thousands of times brighter than a quasar if we manage to capture such a distant outburst. Science will practically be able to look into the past of the universe, even though we are separated from many cosmic objects by millions of light years away. Over time, humanity would be able to understand their nature, evolution, and structure. Perhaps someday the secrets of gamma ray bursts will also be revealed, and who knows what even more amazing objects they will help us find. I hope you enjoyed this video. If you want more interesting information about space and astronomy, be sure to subscribe to our channel. Don't forget to like this video so we know you appreciate our content, and leave us a comment with your thoughts and questions. Thank you for watching. Join us, and see you soon in the depths of space.